Alright, welcome back. This is Moving Man Part 2. Problem 3 says a moving man starts at a position of x equals 10 meters and travels with an initial velocity of negative 6 meters per second and acceleration of negative 1 meters per second squared. Draw the three graphs. Like we talked about in the last video, a great place to start on this problem is with a velocity and time data. Initially, our velocity we can see is negative 6 meters per second. And as time goes along here, we can see that the acceleration is negative 1 meter per second squared. What this basically says is the velocity changes at a rate of negative 1 meters per second every second. So after 1 second, the velocity would then be negative 7 meters per second. Another second goes by, negative 8, and negative 9, just like this. So we can see that the velocity changes at a rate of negative 1 meter per second every second. Later on, the problem asks for 10 seconds as well. So at 10 seconds, if this pattern continues, we can see the velocity would then get all the way up to negative 16 meters per second. So if we graph this data right here, we basically have a velocity versus time graph. So you can see initially the velocity is negative 6 meters per second, and after 10 seconds goes by, the velocity gets all the way up to negative 16 meters per second. And we can see this data looks very, very linear. So we were to graph this data right here, we can see that basically we're going to get a straight line right here, and we can get the velocity graph fairly quickly. Looks just like that. Alright, so we can see that this velocity changes at a constant rate, and we know that the slope of this graph is the acceleration. We know that the slope of this graph is the change in velocity over the change in time. And we can see that in this case, the velocity changes at the rise of this right here. The rise is negative 10 meters per second, negative 10 meters per second, and the run right here is 10 seconds, which gives us the acceleration of negative 1 meters per second per second. So we can see that this is consistent with what we're given right here. That's a great start. All right, if we go ahead and graph that acceleration, once again we see the acceleration is constant right here. Let's go ahead and graph that. Acceleration does not change. It's always the same. And if I label that right there, it's negative 1 meter per second per second. All right, we've got our velocity graph. We have our acceleration graph. Let's go ahead and work and get our position graph. On our position graph, we can see that we start off at x equals 10 meters. Make this graph a little bit longer. We start off x equals 10 meters. And we know that the slope of the position graph gives us the velocity. So initially, when we start off, our slope is going to be negative 6. And when we finish at 10 seconds, our slope is going to be, since the velocity at 10 seconds is negative 16, that means the slope of the position graph will be negative 16 meters per second. So it's going to be even steeper in the negative direction. So as we go along here, our slope is going to increase in the negative direction as it corresponds to the velocity. So let's go ahead and try to draw that. This is should be a consistent graph, something like that. This is a quadratic equation here, so if we take the slope of this graph right here, we will get a velocity of negative 6, and the slope right here, once again, if we take that slope at that point right there, the slope of a tangent to that point right there, the slope should equal negative 16 meters per second. So those are the three graphs. We are also asked to determine how far the moving man moved during the first 10 seconds. We know that the area beneath the velocity graph determines the position, or determines the displacement. So if we figure out the area of this thing right here, that will basically tell us the displacement of the moving man, how the displacement of the moving man. So if we want to figure out that area, we can see that we have both a rectangle and we also have a triangle. So we go ahead and we want to figure out the area of this thing. It is a trapezoid, but a nice easy way to figure out the area of this thing is to divide it into two parts. We have a rectangle and a triangle. We can see that the area of the rectangle is the length times width. So we have 10 seconds times -6 meters per second. Seconds cancel, and we get -60 meters. We also have the triangle right here. This is a 1/2 the base times the height. So the area of this triangle, 1/2 the base. The base we'll call 10 seconds. And the height right here looks like from -6 to -16 is a -10 meters per second. Cancel out seconds. We can see right here that this area of the triangle is -50 meters. So in this case right here, the area of the triangle together, is going to be the sum of these two displacements, which will be -110 meters. So from where we started at a +10, and our displacement is -110. So from where we end, we should be in the negative x direction, 110 meters. So if this is 10, the final position then should be -100 meters. So at 10 seconds, our final position will be -100 meters. So how far did the moving man? It doesn't even make sense right there. How far did the moving man move in the first 10 seconds? In this case, started at 10. It looks like he moved a total distance of 110 meters. All right, those are the three graphs. Once again, the slope of this graph gives you this graph. The slope of this graph gives you this graph. The area of this graph gives you the change of velocity. The area of the velocity graph gives you the displacement. Just to double check that this last part works, we just said that the area of the acceleration graph gives you the change of velocity. And we can see that the area of this rectangle right here is going to be, it looks like 10 times 1, which is 10, which means that the change in velocity right here is going to be 10 meters per second. It's also below the axis, so it's going to be -10. And we can see that that's basically what happens to the velocity. It started at -6 and went down to -16, which is a change of -10 meters per second. So it's consistent. All right, hope that helps out. All right, have fun.